Once we've acquired the data, we come to this section of the software to do the analysis and see what it tells us. Let's go ahead and open up a file, and we see that it's in this directory by default, C Update International Smart Sensor Data. That's what it'll be put. You can put it anywhere you'd like, but you'll have to navigate to it each time if you don't use the default. So we see a record here. We see the name and the data. First thing you want to do is be sure that you've put the phase cursor onto what is the 1 times RPM. And in this case, I see here that it was an 1800 RPM motor. That's the highest peak in that expected area. We want to drag this dotted line phase cursor to that number. And every time you move it, say you want to recalculate phases, because the system will calculate phases on any given frequency. So yes, and you'll see that here is the phase cursor number. We can enter in directly and make it jump to it, or we can drag the cursor. They're tied together. Okay, now that we've got these tied together, we can take a look at the data and see it in this FFT tab. These are navigation zoom in and zoom outs, which high resolution data you need a lot of. Auto scale X for auto scaling, auto scale Y. We can zoom in, drag, hold the cursor down and mark it out. We can do the same thing here, drag, hold the cursor down, marquee, zoom in and zoom out. We can undo those zooms, come back to where we want. So here's our navigation in and out. We can go ahead and place a cursor in any given screen. This will center it. Here's a blue cursor. Blue cursor will give you given values. Now we want to put it on this peak, and this will tell us the amplitude and the frequency of that blue cursor. Sometimes you want to make sure you get it right on the peak, so you'll end up zooming in, make sure you get it right on that peak, and then back out and back out, and we'll see the peak value. Now whenever we have any given data in here, another navigation piece is we have 3 different plots here: horizontal, vertical, and axial, all by color. And you can see here that we can toggle on and off the phase and the data itself by doing that. So let's make it a bit clearer, and really we see the 3 different plots, and as we turn on and off, they just toggle on and off. It's going to happen for the whole system. Now on this cursor, we see the given cursor value in these slots, but that's for the vertical cursor. We can track the horizontal, we can track the axial, we can clean it up if we're, say, tracking the horizontal, and turn them off and just look at the horizontal plot. So that's navigating around. This blue cursor centers and the value from what the cursor is there. Also off the blue cursor is that we can toggle on and off harmonics. So if we turn on harmonics and take a look at the whole plot, here's a harmonic plot based on that start point, and we can turn those off. We can also throw on at a given window, no window, a Hanning window, which is common for frequency accuracy, flat top, common for amplitude accuracy. Over here we can control the units. Right now we're in velocity. We can switch the whole plot to acceleration, velocity, displacement, and we'll default these values here. You can select them, but we'll default them what is common. So displacement is commonly peak to peak, but we can also see the other units. You can also switch between imperial and metric. And so now we're in displacement, peak to peak. We see we're off scale, so we want to auto scale, zoom in, take a look at what's going on down low. Low frequency is where you want to be in displacement. As we grow up higher, and we have a little slider navigation here too, as we go on up higher, we want to either be in velocity or even acceleration. So those are the common plots here. We see a given zoom in level, and now we want to compare the top to the bottom. I can just simply toggle this top or bottom and match the scale. So if I want both to match the scale X and Y for the top plot, I hit top, and notice how the bottom changes. Or similarly, if I was in a bottom zoom position and I want to match the bottom, I can match the bottom. That's what those are. Over here we can switch Hertz CPM for units. Again, that's our phase cursor. If I want to look at different plot points, here is our navigation, identical to the acquisition part where I can navigate between two different units. These are the units. We could see that the units are phase synchronized because they're both green. And here's the data possible from those units. So here's this inboard horizontal, vertical, and axial channels in this plot. Here's the outboards in this plot. They are both completely identical. I can navigate and see these would be identical plots right here. Or I can look at the different ones and compare. Notice on the back I did not take any back readings, so therefore they are red and not there. And we can be on any given point, any given position of the whole unit train. Wherever you want to be, you can just make the plot to the right match. Also, for the plot to the right, we have the three different types. We have the frequency domain, which we've just gone through. We have the time domain, and we have the statistics. Let's take a look at the time domain here. I'm going to go ahead and auto scale here. Turn that off. In the time domain, it's a long duration time domain, so what we generally are looking for are long-term trends. If the whole thing is not centered on zero, say it's all shifted up, you might have some kind of a rub going on or constraint. You can see various time bits of information of jolts and variations that happen in time that you simply cannot see in a frequency domain. Here again it's high res, so you're going to be zooming in an awful lot. We want to zoom in, take a look at, say, what's going on in this region. And very often you want to see what is going on with a given peak. So we want to track a peak and say we want to do this vertical peak to this peak and know what that frequency. When I center a given cursor here, I get two of them, a yellow and a blue. And notice it's not tracking, it's tracking on the horizontal. So I want to switch that to the vertical. And too many is a little confusing, so I'm going to turn these guys off. And now put that right at the peak. And right at the peak, and assume this is just a full cycle. And in fact, it's almost 1800. Here's our frequency and the time duration between the two cursors. And in fact, it is. And therefore, these would be multiples. 2 times, 3 times, whatever they turn out to be. This is another handy tool. It takes a cursor, centers it, drag it to your given peak, and all the corresponding cursors will match out. Let's zoom out, so we got a number of those. And what are they all telling us? They're telling us, again, from a repeated cycle standpoint, what's going on for this given frequency, and this particular given frequency and this spacing is all based on what we have set here for our phase cursor. This phase cursor is telling us a given frequency and therefore space that frequency here with this. We can toggle it on and off, and again, as we toggle it on and off, I can zoom in, say I want to do it on this particular peak to see is that all the same. Back up zoom and see, yes indeed, there's our one-time signal in the time waveform. Statistics. Here we have a listing by channel, so we have to select the given channel that we're looking for. We will see the units right here in acceleration, velocity, displacement, imperial metric, and then what those given values are. So here's the peak to peak value, here's the peak value, here's the RMS, and the crest factor. Now notice right here in this particular one, ISO pops up. Reason being is that this is the ISO standard for an overall value. It is RMS, 10 to 1000 hertz in the range and in velocity. So we just kind of flag that, which is not these values. There are other reasons to look at, but this is your ISO meter reading if you had a pen or something like that. We can navigate to any of those at any time. Over here, when we turn this on, we can see the actual phase relationships for that given position and those three channels. So it's a quick and easy phase reference for both of those. And when we want to take a little bit more input into phase, we can go to the suggestions. One last thing here, we have a bandpass filter. The bandpass filter is very, very useful when we are in the time domain. When we take a look at the time domain and we see all this jazz, and it sometimes gets a little confusing, especially with several plots. We want to clean that up a little bit and get rid of some of that high frequency when we're doing, say, a 1 versus 2 times RPM comparison, or 2 to 3. So what we're going to do here is we're going to go ahead and throttle down. We can either drag this as a slider, or we can enter in the number. So if I wanted to look at the 18 and 3600, which is 1 and 2 times, say we'll end it at about a little over 4000, and bring this up to say 1500. So 1500 to 4000, that should give us the 1 and the 2. And notice how it really cleans things up, because I'm only looking at that particular narrow band. So when I'm coming in and looking at the detail here, I can see it much more cleanly as to what those given frequencies are truly doing in that frequency band range. It really helps highlight and emphasize and see how they are relative phase to each other, etc. Now, just one precaution: when I've band passed this, I've gotten rid of everything else. So when I pop out to the time waveform, oh, where'd all my data go? Just remember, I've banded them out. So if I want to see them, I can bring them out, and notice they start to show up. We're not deleting anything. You can do anything in all of the software. You will never hurt or modify or change your original raw data. That's one nice thing, is to manipulate and mess around with confidence. One last piece here. This is to create a picture. This is for reports. Take any given zoom level that we have. So say I'm in here and I want to really say, hey, here's our 1 times, but here's the 3. This one is the one I'm concerned about. That's auto scale. Let's match that to the bottom. And this is the guy I really want to take a look at right here. And I can just go ahead and snap a picture. And what this will do is create a picture for me, thrown into a directory that I can now drag onto a Word document and use it in a report at a later time.